Hello everyone, I'm Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on effect of source inductance in the converters, control converters. Now here, these are the types of rectifiers already we discussed: single phase off wave control rectifier and single phase off wave full wave control rectifier. After that semi controlled rectifiers. So now here, so first, what is the effect of a source inductance? So previously, so there is no inductance, but here there is a inductance. Because of the inductance, so here in the previous section there is no inductance, but here we have one extra inductance here. So without inductance, I will explain first. So first here, without inductance, if you give the AC supply to the SCR, so SCR will conduct from alpha to will conduct from SCR will conduct from alpha to pi, and from pi to 2 pi SCR pi to 2 pi this freewheeling diode will conduct. So now here this is a supply voltage. This is a supply voltage. So from 0 pi to pi, this is a Vs voltage, and now here this is a alpha. From alpha to pi only it will conduct, and next half cycle it will not conduct, and next at 2 pi plus alpha 2 pi, this is 2 pi, and 2 pi plus alpha again it will conduct up to 3 pi. So this is the case for without source inductance. So now here another one is here. So ITR, this thyristor current is up to pi only, alpha to pi only, and next freewheeling diode current is from pi to 2 pi plus pi. So this is pi to 2 pi plus alpha. So this is the freewheeling diode. So this is the IT, and this is the IA of the current. So this is the case without source inductance. So without source inductance, this is the waveform. But here we are adding one extra inductance, that is source inductance, that is LS. So now here inductance means here because of this inductance. So what will happen? So here this is alpha. It will here this is the alpha. Here we are giving firing pulse at alpha. So directly thyristor will not conduct directly. So it will thyristor current will not increase from 0 to from 0 to I naught. From 0 to I naught. This is the I naught current. So it will take some time to reach I naught. So it will increases, thyristor current will increases linearly, so having with some slope. So this is just because of this source inductance. Inductor does not allow sudden changes in current. It won't allow the sudden changes in currents. It will opposes the current changes. So here it will not here directly it should not come. It will not come like this. Okay, now it will increases linearly like this. So this is the not case. So it will increases linearly like this. Similarly, freewheeling diode current will decreases linearly like this. Okay, now having some slope, it will not go from I naught to 0 quickly. So it will take some time. So this duration is known as the mu. So that mu is the overlap angle. I will define the overlap angle. So first here in this duration, thyristor and freewheeling diode are conducting. So overlapping time is defined as the angle for which all the switches will conduct at the same time. So here, what are the switches here? Thyristor and freewheeling diode. Thyristor and this freewheeling diode. This SCR and this freewheeling, the angle for which SCR both are conducting. This is the mu. Up to this pi plus alpha plus mu, it will conduct. So after that, it will reaches to maximum value I naught. So now here, when mu and when thyristor and for freewheeling diode will conduct. So now here, this is the freewheeling inductance and this is the supply voltage. Thyristor T1 and next here freewheeling diode will conduct. So now what is the output voltage here? Output voltage equals to Vs equals output voltage equals to 0. So now here, because of uh, because of this source inductance, adding source inductance, output voltage is 0 because both SCR and this freewheeling diode conducting at a time. So this output voltage value is 0. But um, in case of without source inductance, it follows the supply voltage. Either thyristor will conduct or diode will conduct. But during this overlap angle mu, so SCR is conducting and next freewheeling diode is conducting. So now here, this output voltage value is 0. Output voltage value is 0. This output is 0. So this output voltage is 0, and in thyristor current is linearly like this, and freewheeling diode will uh, decreases, thyristor is increasing from 0 to I naught, and freewheeling diode current decreases from I naught to 0, having with some slope. So this is the scenario. So here, because of this source inductance, what are the main effects here? So here, this output voltage, previously it starts from here only. So now here, the output voltage is V naught is reducing because of source inductance. Because of source inductance increases, output voltage is reducing. And next, so source at a time, freewheeling diode, all switches will cut. Freewheeling diode and T1 will conduct at a time. So output voltage is 0 during overlap angle, and next here V naught is 0, and conduction time for SCR will increases. So conduction time for SCR will increases means it will, so SCR is conducting from alpha to pi plus mu. So now here, from pi plus mu minus alpha, that is pi minus alpha plus mu is the SCR conducting time. So here, because of this source inductance, so SCR conduction time increases, and next here, output voltage, average output voltage will decreases, and next here, at a time, freewheeling diode and thyristor SCR T1 will conduct during this overlap angle. This both are conducting, all switches are conducting, and during this overlapping period, so the output voltage is 0. So these are the three main effects. Mm. And now, if you another thing is here, what are the output voltages? Means, what about the output voltage? Output voltage equals to V naught average equals to V naught old one. So in without source inductance, what is the output voltage here? Without source inductance, so V naught average equals to 1 by 2 pi integral of alpha to pi Vm sin omega t. So that equals to Vm by pi 2 pi 1 plus cos alpha. So this is V naught average, that is old one. So now here, what about the V naught average? So with source inductance. So now here, this is the new one. So this is new one. So that equals to 1 by 2 pi from alpha plus mu to pi. It will conduct from alpha plus mu to pi. So now here, alpha plus mu to pi. So Vm sine omega t d omega t. So now if you calculate V naught average nu is equals to Vm by pi. So 1 plus cos alpha plus mu. So this is the case. Now here what is the reduction? Here because of the source inductance, so this output voltage will reduces. So now here the reduction in output voltage V naught equals to V naught old minus V naught mu. So now here that is Vm by 2 pi cos alpha minus cos alpha plus mu. So this is the delta reduction in the voltage. So this much amount, the delta V. So now reduction in the voltage. So now here what about the I naught output current equals to I naught equals to. So now here output current equals to, because of this inductor current, output current equals to, here this is the inductor, this is the supply voltage, this is the short circuit T1, and this is the diode, and next this is a VL and this is a VS. Now here VL equals to VS. Okay, now Vm sin omega t, and VL equals to L di by dt. So now here di by dt is equals to Vm by L sin omega t. Now here if you integrate from alpha to alpha plus mu, and this is integrate from 0 to I naught. So now here this is I naught equals to here. So Vm by omega L sine omega t, sorry, cos alpha minus cos alpha plus mu. So this is the I naught formula. So now here what is the formula for? So now here I naught equals to Vm by omega L. Now here cos alpha minus cos alpha plus mu. So now here, so omega L is equals to omega L into I naught equals to Vm by cos alpha minus cos alpha plus mu. So now divided by 2 pi, this is 2 pi. So now this is the delta V naught. So now here delta V naught equals to this, sorry, delta V naught equals to here, delta V naught equals to delta V naught equals to delta V naught equals to. So now here omega means 2 pi f. 2 pi f means here you can write is from f L I naught, we can write it as. So now here what are the conclusions? So first conclusion is here. First one is the, because of this source inductance output voltage will reduces, and at a time during overlapping all switches will conduct this SCR and this diode, freewheeling diode will conduct, and during that period output voltage is 0. And next here conduction time is increases, that conduction time is pi minus, this is pi plus mu minus alpha. So now here pi minus alpha plus mu, and next here output voltage is, this is old one, and the new average output voltage is Vm by 2 pi 1 plus cos alpha plus mu. And now reduction in the voltage, this voltage equals V old minus V new. So that equals V naught equals Vm by 2 pi cos alpha minus cos alpha plus mu. And now here here during because of this source inductance, this both are conducting means supply voltage equals to inductor voltage. So inductor voltage means L di by dt is equals Vm sin omega t. If you integrate from 0 to I naught, di by dt is equal to integral of alpha to, from alpha to pi plus uh, alpha to alpha plus mu Vm by L sin omega t. If you simplify this, I naught Vm by omega L cos alpha minus cos alpha plus mu. So now here this one is a equation, and if you divide V W L omega L into I naught is equals Vm cos alpha minus cos alpha plus mu, divided by LHS side and RHS side by 2 pi, So now here this is the reduction in voltage del V naught equals to, here omega means here 2 pi f. Here 2 pi gets cancelled, f into L into I naught. This is the reduction in the voltage. So this reduction in the voltage is depending on the source inductance. And now what about for this full wave rectifier, full bridge rectifier? So here is also same. In the previous case, um, here, um, so without source inductance, first I am explaining. So after that I will explain. So without source inductance, first I will explain. First, during at alpha T1 and this T1 and T2 will conduct. So from alpha to pi plus alpha, from alpha to pi plus alpha, this must be here. And next from pi plus alpha to T3 and T4 will conduct. T3 and T4 will conduct, and next T1 and T2 will conduct pi plus alpha. So this is the case for output voltage of average output voltage of for full bridge inverter. But here, what is the range? This range. So because of source inductance Ls. So here the output voltage will reduces. Already we have seen in the single phase out bridge of the inverter, because of source inductance. So it will not conduct from start from alpha, so it will take some time to reach from uh, it will take some time. So here this is IT1 and IT1 and IT2 and IT3 and IT4, IT3 and IT4. So for first, sorry, this is IT3 and IT4, IT1 and IT2. So first IT1 must start IT1 value. First, what will happen because of this source inductance? What will happen? So here T1 and T2 will conduct. Okay, na? Again, it will not move from minus I naught to I naught. So it will take some time to reach from I naught to minus I naught to I naught. So it is having some slope. It will not reach quickly from minus I naught to I naught. It is having some slope. This is just because of inductor. Inductor does not allow certain changes in the current. It won't allows the uh, current changes. So that is the property of inductance. Because of that inductance property, so now here T1, T2, T3, T4 will conduct. So this is the overlap angle mu. So here all the switches. What do you mean by overlap angle? The for angle for which all the switches will conduct at a time during that period. So here this is the source inductance. Here this is this one. Okay, now all the switches will short circuited. This is the load, so output voltage is 0. So here, because of this source inductance increases, so all switches T1, T2, T3, T4 switches will conduct, and next here that output all will conduct. Okay, now all the switches will conduct, and V naught is 0 during mu duration. So this duration output voltage is 0. Because of this, total average output voltage will reduces. So this is the reason. And after that, this is pi plus alpha plus, this is pi plus alpha plus mu. Here this is T1 and T3, T2 will conduct, and T3 and T4 will conduct. So this is T1 to T3, and T3 and T4 current is also not decreases suddenly from I naught to minus I naught. So that we will see. So now here, what about the output voltage from old, so without source inductance? So now here that is without source inductance 2 Vm by pi cos alpha. So now here v new equals to, so that is V2 Vm by pi cos alpha plus mu. This is nu. Now what is the reduction? This is just because of inductance. So what is the reduction in the voltage? What is the reduction in this voltage? So that equals V old minus V naught old minus V naught new. So now this equals to, so now 2Vm by pi, 2Vm by pi cos alpha minus cos alpha plus mu. So this is the reduction in the voltage. So now here, um, here. So now here, during alpha, this is during overlap angle, all SCRs will conduct only all SCRs, all T1, T2, T3, T4 SCRs will conduct. This is Vs and this is a VL. Only here Vs equals to VL, so that equals to L di by dt. So now here Vm sin omega t is equals to L, L di by dt. So now if you integrate from minus I naught to minus I naught to I naught, so this is, and now here this is from alpha to alpha plus mu. So now here this equals to, this is alpha to I naught, this one equals to minus Vm by omega L cos alpha minus cos alpha plus mu. So this is the equation. So now here, what about your this one? This is 2Vm by 2 multiply with 2. 2 if you multiply with 4, so 4 2Vm by. So here this is the case. So 2Vm by pi cos alpha. So that one equals to here uh, 2Vm by pi, 2Vm by pi cos alpha minus cos alpha plus mu is equals to, here 2 means here 4 I naught into omega L. So now here this is also divided by pi. So now here this is 4 pi. So now here 8 pi I think. So now here multiply with 4 pi. This is 2. 2 2 and 2, and again 2 pi and 2 pi, 8 pi. So now here, so 2Vm by pi, this one is a del V, delta of V naught reduction in voltage, and now here 4 omega 4 into F into L into I naught. So this is the reduction in the voltage. What is the conduction time? So now here this is the alpha. So this is the alpha. This one is the pi plus alpha. So now here, so in the previous case that value is gamma of t equals to pi only, here pi plus mu. Conduction time equals to pi. So now another one is, this is just because of inductance. So now another one is here, fundamental displacement factor is equals to cos of alpha plus mu by 2. So in the previous case without source inductance, so that is only cos alpha, but here just because of this source inductance, this value is alpha plus cos alpha plus mu by 2. So now if you what are the conclusions here? So here because of this source inductance, all switches will conduct during that period. So overlapping period, output voltage is 0, average output voltage will decreases. So now here that is just because of source inductance, and this is a without source inductance output voltage, and with source inductance output voltage. And next, the reduction in the voltage formula, 2Vm by pi cos alpha minus cos alpha plus mu. So now here with source inductance, all switches are short circuited. So Vs equals to VL only. So VL means L di by dt. So now here alpha to alpha plus IVM by omega L. So now if you simplify this one, so this is the formula, V naught equals to 4F L I naught. So now here conduction time is gamma of t equals to pi plus mu. So now here fundamental displacement factor equals to cos alpha plus mu by 2. So now here, what about the three-phase full converter? So now here, so 3 V naught average old equals to, so that equals to 3 Vm L cos alpha by pi. So now here V naught average nu equals to 3 Vm L by 2 pi cos alpha plus cos alpha minus cos alpha plus mu. So now here reduction in the voltage equals to del V naught equals to here. So now here 3 Vm L by 2 pi cos alpha plus mu. So now here what is the output current equals to I naught equals to here the del V naught equals to, what is the formula here? So now here del V naught equals in terms of I naught equals to same. So now here 6 into F into L into I naught. This is the formula. Now last one is the fundamental displacement factor. So that equals to cos alpha plus mu by 2. So this is most important. Now, so these are the cases for three-phase full bridge inverter with source inductance. I hope all these concepts are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.